So I'm going to overview the generators. We have removed the covers, spindle covers and the x-axis covers, so you can see the machines how it looks like. I also removed this side cover so I can show you the amplifiers. This machine built on air bearings. Spindle has air bearings. These are linear bearings over here. These are x-axis. These are air bearings. The Z prime is air bearings as well as the REX is air bearing. That means when you run this machine, you need really clean air. You need to put the chiller on it, you need to put the dryer on it. If your air has oil or moisture, it can first kill the spindle. Spindle is very expensive. Nobody make in USA. We send it in UK for repair or maintenance purposes. So just make sure you use a dry and clean airs on it. So when you receive the machines, unpack it, look at the machine, make sure it's physically not damaged from anywhere. On this side, this is amplified side, and if you see there's some data cables over here, and we are using 5 amplifiers. This is amplifier for, it's got 400 for C axis, this is for Z axis, amplifier 500 for X axis, for RE axis, amplifier 300 for Z prime, amplifier 100 for X axis. So 5 axes have 5 amplifiers, and each amplifier, top 2 have lights here. If amplifiers are good, these green will on. If there's a problem, one of these lights turn on, so you can call us and let us know which light is on. These are LCD displays, so you will see display over here. If it's 0, it means it's good. If there's any alphabets or anything else, that means there's some message. So amplifier have safety valves on it, so if there's an overvolt voltage current or amps, they will turn off immediately, so you don't burn off your amplifiers. This is IM1 cable. These are TB501, 301, 101 cables. This is IM2 cables. This is IM3 cables. These are connected inside in the computer, which have a program and the DMC board, which control all the motions. Okay, so what we're going to do, we're going to turn on the machine. This is main switch. This switch is off. I'm going to turn on this switch and turn on the machine. So machine is turning on. I have a air on this side. I'm going to turn on the air. We use 80 psi pressure. So we're going to start window. So I'm going to first show you how to test the machine before you run for productions. When you receive, this is only when you receive very first time, and we are not coming for training. These are few things you have to test it before you run your machine. So Windows starting up, let me show you this keyboard having few switches here. This is cycle start switch. So whenever you have to start the cycle, you have to press board. This is amps on to turn on those amplifiers. That's emergency switch. You always keep pressed down if you're not running the machine. Abort cycle, if something happened, you want to abort the cycle, you press this one. So this is on. We have 2 programs here. This is our main program, and this is our, it's called TI menu. So I'm going to start with TI menu first, and you will see a bunch of numbers here, and then you have X axis, Z axis, A and C. All numbers are 0. I'm going to use E finite, E, F, I, N, I, G. Okay, and I press enter, and you see it's a bunch of files and numbers are changed now. Okay, so we have to load these files. What I'm trying to do here, I'm going to check if machine is okay to start up. Okay, so I load these things and I'm first going to check signals. We have different signals here, so I'm going to check for C axis is ASC, press enter, and I'm going to press L in the keyboard. So this is my circular signal here, and if I spin my spindle, and this is pretty good, so I like this signal. So this is 1 volt, 2 volt, 3 volt, 4 and 5. Signal has to be above 3 volt. It can be 4, 3.5, 4.5. Cannot go beyond 5, cannot be less than 3. If it's less than 3, your machine will not start. So that's what I'm checking, if my signals are okay. So this is for C axis. I'm going to check X axis, and this is my X axis. I'm going to tap it, and this looks pretty good. I'm going to check Z A axis, which is my Z prime, and I'm going to tap my tool holders. This is where my diamonds are. So if I tap them, this is good too. It's circular and is about 4¼ and I got C, X, A, and I need to check R axis. This is for the R axis. This is also good, 4 volt. So this is what I want to check it. So these are the 4 signals you have to check it. For the Z axis, which is this one, where spindle move back and forth, we have a encoder here, a motor here. This is the axis encoder, motors. We don't have a program to check this signal, so you don't need to check it. This is always fixed and it's always working. This is a coupler between lead screw and the motors. This coupler moves this spindle back and forth. This axis called Z axis. Then we have, if you move camera on this side, Hector, I can show them. This one is C axis. This is spindle. You see it's spinning. It's freely moving. There is no restriction on it. As soon as you touch it, it will move. This is air spindle. It should not have any friction or anything. If you feel any friction or binding, that means there's something wrong in the spindle. It's not in a good shape. So this is C axis, is moving good. This is X axis. This move back and forth. And this is our E axis for counterweight. And these are the 2 tool holders we use it, and I will show you later how to put the diamonds on it and how to do calibrations when you replace the tools. This one here is a probe we use for calibration purposes, and these are 2 wise coils which we use for those RE axis and Z prime axis. Now all 5 axes have encoders, like Z axis have encoder here, spindle have encoder here. So if we move these 2 screws, we remove this one, there's encoder inside on it. The X axis, you have encoder on this one, is mounted here. So if you remove this wire box, there's 2 screws here, 2 in the back. If you remove it, you will see encoder inside it. There's an encoder here for Z prime, and there's an encoder here for RE axis. Now each encoder has a mounting plates. If you can see, this is encoder, this is mounting plates. So the signals I was showing you, like for RE axis, ASR, when I move this one, the signal move. So for some reason, if something happened, your signals are crash, is not coming out to be 4 or 3 volt, you have to adjust the signals from your encoders. So you can either move this encoder, or you can move this plate, or you can move this mounting plate. So you have to move very minorly, very small movements like in microns, because this is very sensitive in terms of moving. So once we check all signals, we check it for A axis, we check it for R axis, check it for X axis, check it for C axis. When all signals are checked, I'm going to release panic switch. This is the recovery here. I'm going to turn on the amps, and you see recovery is gone. So I'm going to enter shake, wake, X. So this move a little bit, shake and wake for X axis. So my amplifiers are on, and if my guy can show you these amplifiers here, this is very normal procedure and setting. So if you see, all the amps are 0, 0, 0, and top 2 amps, they are green. You got it? So this is how your amplifier should be. Another thing, if you want to check it, you can check the voltage on these amplifiers against these two wires, black and red. The top 2 voltage should be 300 plus minus 15, and bottom 3 should be 55 plus minus 3. And this is the DC voltage. This is not AC voltage. Okay, so once amplifiers is on, my machine is ready to go. I can press do. It will exit TI menu, and I'm going to start up RxT menu. So in RxT menu, when you start up, is going to initialize different axes to make sure everything is working. If there is any problem anywhere, your amplifier may not turn on, one of the axes have problem, it will fail in initialization. Okay, so once it's done, machine is ready for production. So before we do production, we have to run, this is our main screen, and you can see there's a different options here. F5 is for production, F3 is for maintenance. So we go to F3. So in the morning, very first thing you do, you press the machine, you go warm up and press enter. This will warm up the machine, you move all the axes for a few minutes, at least 10 to 50 minutes, and once it's done, then we will do the calibration. Okay, so once we warm up the machine for 10-50 minutes, machine is ready for calibration. First thing is spray vacuum controls. You select it, press enter, you press plus, and make sure there's a solution is coming out from the roughing. Press 2, spray 2, solution is coming from the finishing. Number 3 is vacuum, vacuum is on. These controls are here on this side, and these will be labels. One is for the air, one is for the water. So you put a mixture of water and air. We use a mist in this tank, so it's a solution and a water composition with the 1/20. So 1 cup of chemicals, 20 cup of water, we mix it together, and we use this in the cutting process. So it's a mist technology. So these are control here, one is for the water, one is for the air, for one roughing, one finishing. So once we test this one, we press escape, do calibrate probe, press enter. So you see these numbers important. 25.4 is written here, 25.4, you make sure you have same number, press enter. 5.1 is written here, 5.1. So once these are confirmed, you put it on, press enter, cycle start. You're going to do probe calibration. This is procedure we do every day before we run the machine.